All right, we've been working on quadratic equations. Remember that quadratic equations have the highest exponent of a 2. The 2 is what makes the parabola, what makes the U-shaped curve of a quadratic. We looked and we talked about the quadratic parent function. You need to have this memorized. When I ask you what is the quadratic parent function, you should be able to tell me y equals x squared. You also should be able to identify this table. And when you're looking at the graph, please remember that at first the curve right here is called the parabola. You should be able to look at it next and see the vertex. The vertex is the point where the parabola changes direction. The axis of symmetry is x equals whatever the x number is of the vertex. I have a lot of people that are going through and telling me it's always x equals 0. That is not true. You have the axis of symmetry only goes through one point. It only goes through the vertex. And so it's a vertical line and it goes through the vertex. So it's x equals this x number right here, the vertex. I should be able to look in a table and find my symmetric pairs, and like 36, 36, 25, 25, 16, 16. You will find that the vertex is the only one that doesn't have a partner in the y. Now, so symmetrical points, the reason why they're symmetrical is because they are the same distance away from the AOS on each side. So like this top one up here, I have 3 to the right, 3 to the left. 2 to the right, 2 to the left. They're the same distance. Now, some people tell me what I found yesterday. When I asked people to tell me the symmetrical point for negative 636, they did not look to see for the same y value. They just assumed it was always like if this was negative 6, that the other x number is positive 6. That is not always the case, and we'll see that in just a second. Remember, now this is what we're going to start talking about today. This parabola now has a minus 7 at the end. That means that it is shifted down 7 units. See, because now when I go and find my vertex, as I'm going through and with my symmetric points, I find that I have 0, negative 7. My axis of symmetry, again, is x equals 0. That's because the x number of the vertex is 0. And my symmetric points have the same y values. The other one that we talked about, which we'll talk about this form in just a second, this parabola is shifted down and to the left. Well, you should be able to look at this table and find the vertex. I have to match up, like here it says 9, I find a 9. 2, I find the 2. Negative 3, negative 3. And I go through and you should be able to find the vertex on a table and on a graph. This one is a great example, again, that the axis of symmetry is x equals whatever the x number is of the vertex. So it's x equals negative 2. Then you have symmetrical points. All right. So now, the other thing, let's go, oh, gee, all right. Well, it's not letting me, let's see if I can. There we go. So on your paper you have in front of you, it says, the first thing it says is the standard form of a quadratic equation. Standard form for a quadratic equation, you need to have written down, is y equals ax squared plus bx, oh, that's not an x, plus bx plus c. That's the standard form. We had that the other day on one of our assignments. Then it says the quadratic parent function. You should know that the quadratic parent function is y equals x squared. Okay? That has to be memorized. Now on number 1, it says fill in the table and graph the quadratic function. Can't talk. Quadratic function y equals x squared plus 4. The parent function values in the graph are provided for you. All right, so what I want you to do right now, let's go get our handy dandy calculator. and pull this up, and you should make sure you clear your memory from the very beginning. Second plus sign 712. Now we're going to go to y equals, and I want you to put in the parent function, x squared. Now, we're going to be doing a lot of comparing to the parent function, so to make sure you know the difference between the graphs, look, see that left arrow key? Press the arrow key to the left. See how it's blinking over here by the y? Press enter. Now when you graph it, it's going to give you a darkened line for that parabola. So now when we go to y equals and we go to y2, I want you to put in there x squared plus 4. Now if you press graph, let's look at this and see. What do you notice about the vertex of this new parabola? The vertex is higher. Okay? So let's look at something. Let me pull up this other. I'm going to pull up this other one. Right now on my board, I have the quadratic parent function. That plus 4, that ending part told me to take this vertex and move it up 4 units. All I did was slide it up. Did I change the width? Did I make it fatter or skinnier? No. It kind of looks like it, doesn't it? On the graph, doesn't it look like it's skinnier? But that's not really what happened, because these narrower parts down here, all I did was shift them up and move them up. Okay? So when we have right here, we have a plus 4 or a minus something or whatever, that does not change the width. It just shifts your parabola up or down. All right, so what it wants us to do now is to go into the calculator, go into second graph, go into the table, and let's fill in our table right here. So I'm going to move up. There we go. I always make it so that I can find the balance on my screen where it says like 994411. So now we're going to fill in our table. It's -3, 13. So right here, let's put in there a 13. So match up these tables. So let's see here. I've got 13, 8, 5, 4, 5, 8, and 13. Okay? So now I need to go and graph these. So remember that you're using the X and this over here in the Y column. So I can start at 0, 4, 0, 1, 2, 3, 4. Now it says let's go to -1, 5. Over -1 and up to 5 and put a dot. +1, 5. Remember, it's got to be symmetrical over the axis of symmetry. I have 4, 8. Oh, no, sorry, not 4, 8. I almost messed up. 2. There we go. 2, 8. Over 2 and up 4, 5, 6, 7, 8. It's the same on the other side here, and I can draw my parabola to connect my points. Now, from here, it says, what do you notice about the y values of y equals x squared plus 4 compared to the y values of the parent function? What do you notice? What has happened between 9 to 13, 4 to 8, 1 to 5, 0 to 4? How did you get from these numbers from the parent function to this new one? Plus 4. So all this did, so how does, what does it compare to? They're all 4 more than the parent function. And that's because they are shifted up 4 units. That's what the plus 4 does. Is that all on that part? maybe. Okay, there we go. All right, so let's go and do the next one. It says fill in the table of the graph of the function y equals x squared minus 2. So let's go back to the handy dandy calculator and go to y equals. And instead of x squared plus 4, let's put in there minus 2. And let's press graph. Now, when you look at this one, let's fill in the table. Let's go into the table, go second graph, and it says when x is negative 3, what is y? So if I go over here to the y2 column, I have 7, negative 2, negative 1, negative 2. So let's fill that in over here in this column. So let's see here. What did it say? 7, 2, negative 1, negative 2, negative 1, 2, and 7. All I did was put the equation in the calculator, fill in my table, and have it match right over here. Now as I go over to my graph, let's go and graph these ordered pairs. So it says 0, negative 2. So I'll put a dot at 0, negative 2. Negative 1, negative 1. 1, negative 1. It says negative 2, 2. So negative 2 and up 1, 2. Over 2 and up 2. I have negative 3, 7. 2, 3, 4, 5, 6, 7. It's right outside that blue line. And then I can draw my parabola and sketch it. Now, as we look at this, again, what do you notice is happening from the parent function to the new function? All these numbers are how many less? They are 2 less than the y numbers are 2 less than the parent function. So, wait a minute. Let's look at some. Take your calculators. What if we put in there, we went into y equals, and we did x squared, and we did plus 6. How would that change my graph if I put plus 6, x squared plus 6? When I press graph, how did it change my parabola? It moved it up 6 units, didn't it? Okay? So on your paper down there at the bottom, here's what I want you guys to understand. Y equals ax squared plus or minus c. At the bottom of that paper right there, this number right here shifts the parabola up or down. That's what that number does at the end. It shifts your parabola up or down. If it's plus 5, it moves it all up 5. If it's minus 6, it moves it all down 6. That is the only thing it changes. It doesn't change the width. It doesn't change the direction, and we're going to deal with that in just a second. Once you have that written down, turn your paper over to the back. And now, as you're waiting on me, go to the calculator and put in your equation into y2 that they've given you on the next one. So as I look here, this time it says now we'll be looking at the effects of changing a. The parent function is already shown in the graph provided. Okay, so we need to go to y equals. And this time, they're asking us to use the equation y equals 2x squared. So I'm going to press 2x squared. What is that 2 doing to the x squared? Is it adding, subtracting, or multiplying, or dividing? When they're right next to each other, they're multiplying, right? So let's go second graph. All right, this time if we fill in the table, we're going to the y2 column. It says where negative 2 is, I've got 8, 8, 2, 0, 2, and 8. If I go to graph those, remember, use the x in the y2 column. 0, 0, 1, 2, over 1 and up 2, negative 1, 2, 2, 8. Let's see if I can see it. There we go. Now, wait a minute. Looking at the graph, what did it do to it? Did it shift it? Did it move it up or down? No. It made that red one is skinnier, right? What's happening between these numbers right here? It doubled it. Why did it double it? Because what did we put in? What was the equation? The equation was y equals 2x squared. So describe what happened. It made the parabola skinnier. The other word they'll use is narrower. Because it doubled the y numbers. The y numbers of the parent function. Now, this is called a vertical stretch. It is a vertical stretch. Make sure you have that down and go to the next one on your paper. All right, so on number 4, right here, what did they ask us to put in there now? Negative 2x squared. So let's go into the calculator into y equals. Let's go down here and I'm going to put, put negative 2x squared. And when I press graph, when I look at this, what happened? Yeah, that parabola is open downward now. Okay, we'll look at that in just a second. So let's go to second graph. Let's fill in our table. So it says negative 2 and negative 8. Negative 8, negative 2, 0, negative 2, negative 8. Did my vertex change? My vertex is still 0, 0. Okay, so now let's go and graph those. So I start at 0, 0. I have negative 1, negative 2, 1, negative 2, 2, negative 8, and negative 2, negative 8. All right. We already said that 2x squared is narrower than the parent function. We already said that. The only thing that's different in this one is your negative sign. So describe what happened. The graph, or the parabola, the parabola is still skinnier than the parent function. But this one is opened downward. Guys, this is a reflection over the x-axis. We'll come back and put all those notes back together in just a minute with what's happening with all these rules. So the negative just makes it open downward. It gives it it makes it a reflection over the x-axis. The 2 makes it narrower. All right, so on the last one that's on these notes, it asks you to put in there 1/4 x squared. So let's go to the calculator, go to y equals, go to y2, and let's put 1/4. 1 divide 4, x, and then this x squared button. Oh, I gotta delete some things. All right, here we go. 1/4 x squared. I press graph. There's my parent function. What happened to this one? Much fatter, much wider. Okay? So when I go into my table, let's fill in my table. It says, let's see, I need a -4. So let's see, it's -4 and 4. And then my 2's are what? 2, -2, 1. And 2, 1. And then 0, 0 still. That vertex is still the same. So now I've got 2, 1 and -2, 1. And 4, 4. So 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. Oop, did I jump up too high? What happened? 1, 2, 3, 4. 1, 2, 3. Oh, there we go. Much better. Let me try and fix that. All right. If you look at all these numbers now, how do you get from 16 to 4? From 4 to 1? You can either say it as you're taking 16 times 1/4. That gives you 4, which is the same as 16 divided by 4. 4 times 1/4, that's where the 1 is coming from. Describe what happens. The new function, or the new parabola, is wider than the parent function. Guys, this is called a vertical compression. I think of it like a marshmallow. To make that fatter, if I push it together from the top and the bottom, right? If I push it together, it makes the marshmallow wider and fatter. If I pulled the marshmallow up and down, it would stretch it. That's a vertical stretch. That's what's happening to my parabolas. So now let's go back where I had you write on the first page. I had you write y equals ax squared plus or minus c. This a right here, first off, it tells you the direction of the parabola. Okay, what I mean is, if it's positive, it opens up. If it's negative, it opens downward. And we dealt with that yesterday because we talked about when it opened upward or downward, and then their vertex was either a minimum or a maximum. The other thing that A does is it deals with the width. Now, the positive and negative have nothing to do with the width. Positive and negative has to do with direction. The width, if the number, or if the coefficient is larger than 1, then the parabola is skinnier. Remember, that is called a vertical stretch. Move my thing up a little bit. If the coefficient is between 0 and 1, so that's a fraction, between 0 and 1, then the parabola is wider, which is called a vertical compression. Now on these equations, you guys are going to have to look and compare what's the same, what's similar, what's different, that type of thing, and what's happening to your parabolas. That's what they're going to ask you to do. But these are the attributes that you need to know. Oops, I don't want that up there.